All right, let's dive right in. Today, we're going to peel back a hidden layer of an operating system you probably use every single day. We're talking about a secret set of tools that are incredibly powerful, totally fundamental, and almost completely off limits to the average developer.
That's a perfect way to put it. This is exactly what it's like deep inside Windows NT. Most developers, right, they're given the standard, safe, high-level toolkit. But underneath all of that, there's a whole other set of services working away, doing the heavy lifting.
So, what exactly are these secret tools? Well, they're called native Windows NT services, and they are literally the fundamental language the operating system uses to talk to itself. Which begs the question, if they're so important, why the big secret? Why are they kept hidden from most people?
Well, our guide to the secret world, believe it or not, is a document called Appendix A. You can think of it like a treasure map, pointing the way to all these undocumented services and giving us a really rare peek into the core mechanics of the OS.
So these services, they're the absolute bedrock of how your computer handles files. When you use a normal command like saving a file, you're really just using a simplified abstraction. These native services, they're what that simple command talks to. They are the direct line to the system's I/O manager. And this right here highlights the fundamental trade-off. On one side, you've got your standard Win32 APIs. They give you abstraction, they give you portability, and they make sure your app is probably going to work on the next version of Windows. But native services, they trade all that safety for raw, direct, powerful control. So yeah, this stuff isn't for your everyday app developer. This is for the people building the very infrastructure of the system. We're talking about the folks writing file systems, kernel mode drivers, people who need that deep, comprehensive control to make things work at the lowest possible levels. Okay, to really see how this works, let's just break down one of these functions. By looking at a single native call, you can get a feel for the incredible level of control it offers. It's just worlds away from a standard API.
We're going to focus on a function called ntCreateFile. Now, in the normal Win32 world, you'd have separate functions for creating a file, opening a file, or maybe chopping a file down to 0 bytes. This one native function, ntCreateFile, it does all of that, and so much more.
I mean, just look at this list. The sheer number of parameter categories is kind of staggering. And each one of these isn't just one setting. It opens up a whole menu of dozens of specific flags and options. This is what we mean by granular control. You're not just opening a file, you're dictating the exact terms of the entire interaction.
Let's just zoom in on one of these, share access. This parameter is absolutely critical in an operating system where a million things are happening at once. It lets you tell Windows precisely how other programs can mess with a file while you have it open. Can they read it, write to it? Can they delete it out from under you? You decide.
And this quote just illustrates the risk perfectly. Because if you get this parameter wrong, let's say you don't specify any share flags, you effectively lock every other program on the system completely out of that file until you're done. You can just imagine the system-wide gridlock that could cause.
Here's another powerful one, create disposition. This gives you really precise control over the logic. File supersede basically says, look, I want a clean file with this name, and I don't care if one existed before, just replace it. In total contrast, file create says, nope, I only want this to work if the file is brand new. It's a subtle but absolutely crucial difference.
And the create options parameter, wow, it's just a treasure trove of specific behaviors. You can tell the system to bypass its cache and write directly to the disk, or automatically delete the file the second you're done with it, or even open a file using its internal NTFS file ID, something that's not at all easy to do with the standard APIs. So right about now, you're probably thinking, okay, if these services are so incredibly powerful and can do things way more efficiently, why isn't everybody using them? Well, that power, as you might have guessed, comes with a very, very significant price. This brings us right back to our original question and the real reason these services are kept in the shadows. Microsoft deliberately puts a layer between you and them because direct access, while powerful, is also really dangerous for application stability. So here it is. The crucial point is this. You are treating direct power for a huge risk. Because these services are undocumented for general use, Microsoft gives you absolutely no guarantee that they will exist or even work the same way in the next version of Windows. An app built on these could just break with the very next system update.
Now, using these directly is risky for sure, but that doesn't mean knowing about them isn't valuable. So let's pull this all together and figure out what the big takeaway is from uncovering this hidden layer of the OS. Understanding that this native layer even exists gives you a much deeper appreciation for what's really happening when you use your computer. That simple file save command in your favorite program, that's just the tip of the iceberg. It kicks off this whole complex chain of events that ultimately boils down to one of these powerful fundamental calls. So, in the end, our little journey into this secret toolkit reveals a world of precision tools. And yeah, they're way too risky for most of us to use directly, but their existence explains so much about how Windows really works under the hood. They're the blueprint that all the familiar, safer tools are built from. And that leaves us with a pretty fascinating thought. This is just one hidden interface for one part of the OS. It really makes you wonder, what other powerful, undocumented systems are just humming away deep inside the operating systems we use every single day, just waiting to be discovered?